Requirements management. Content of this set of slides, we will look at an introduction to requirements management, traceability, baselines, change management, and requirements management tools. Why do requirements change? Change in software development, it is as inevitable as it is difficult to control. So as we gain a better understanding of the system, its context, and the business and how it's going with the people who are involved, the stakeholders, as we gain our understanding of it, new requirements become apparent. So everything else is changing as well, right? The business is changing, the context is going to keep changing, technologies keep changing very frequently, and markets keep changing, right? So because everything else is changing, it is inevitable that the software requirements also keep changing. So possible responses when you do have a change in requirements, possible responses could be to add new requirements, to modify existing requirements, or to remove requirements. Now when you do these actions, some problems may arise. These problems could include requirements changing towards the end of the development without any impact assessment, right? That is a problem. Unmatched or outdated requirement specifications causing confusion and unnecessary rework. And lastly, time spent coding, writing test cases, or documentation for requirements that no longer exist. Now, requirements management is a systematic approach to eliciting, organizing, and documenting the requirement of the system, and a process that establishes and maintains agreement between the customer and the project team on the changing requirements of the system. So there are some activities involved in requirements management. What are these activities? You can be managing changes to agreed requirements. You manage changes to baseline, which means you are adding increments. You keep project plans synchronized with the requirements. You have to control versions of individual requirements and versions of requirements documents. So there's a lot of versions that will be coming up, because with each new change you have a new version. So you need to keep track of all these versions of all the requirements documents, and also versions of the requirements themselves as they evolve. You have to manage relationships between requirements, because they would also be changing. You have to manage the dependencies between the requirements document and other documents produced in the systems engineering process. And you have to track requirement status. Requirements management activities can be grouped like this. You have activities that take care of change control. This is where you would be proposing changes, analyzing impact of the requirements change that's proposed, making decisions about whether you will go ahead with the change or not, updating requirements documents, updating plans, measuring requirements volatility. You have this group of activities, which is in regards to version control. So here you would be defining a version identification scheme, identifying requirements document versions, identifying individual requirement versions. Right? So those are the activities involved in version control. Then you have this group of activities, requirement status tracking. Here you define a possible requirement status, recording the status of each requirement, reporting the status distribution of all requirements. And lastly, you have this group of activities about requirements tracing. Here you define links to other requirements, and you define links to other system elements. So these are groups of activities, right? Activities that are part of the requirements management process. Activities that have to do with controlling change of a requirement are here. Activities that affect or activities that manage the versions are here, and then tracking the requirements and tracing requirements are over here. Right, so requirements development and management. Here you have You start here, marketing, customers, management requirements. You analyze, document, you review, and negotiate. And so you end up with the baseline requirements. Okay, this is before any management has taken place, any new changes have come up. This is the initial set of requirements that you have. So we call that the baseline requirements. Now after that, you can revise your baseline, right? And thus you have begun the requirements change, requirements management area, which includes all these down here. Okay, if marketing, customers, and management, they want some more changes to your baseline, they have to submit requirement change proposals, and then you follow the protocol, right? So that is all now managed. So the baseline requirements is the initial confirmed set of requirements that we came up with. Okay, so changes lead to a need for management. There is no management without traceability and without baselines enabling comparison. So you need to have traceability. You have to manage something, right? You need to be able to look back and see what was changed, when, how, where, and all those details of the change. And also, you can only have changes if you have something to compare it to. Right, you start off with the baseline, which is the initial set, and then you would make changes to that. So you have a clear picture of the baseline. From a practical point of view, there is no traceability or management without the appropriate tools. So requirements change factors. Firstly, requirement errors, conflicts, and inconsistencies. These lead to requirements change. They may be detected at any phase when requirements are analyzed or when they are specified, or they could be detected when requirements are being validated, or even worse, they could be detected when they are being implemented. So that's at the later stage. Another factor would be evolving customer or user knowledge of the system. So when the requirements are developed, customers or users simultaneously develop a better understanding of what they really need, right? So when they realize they need something different and not what was actually done, that leads to a change in the requirements. Another factor is technical, schedule, or cost problems. So it's difficult to plan and know everything in advance, and we may have to revisit the list of requirements and adapt it to the current situation, right? So these are some factors that can contribute to the emergence of requirements change. Some of factors that lead to requirements change include the following. Changing customer priorities. So customers come up with new needs. They may be caused by a change in the system environment, like technological, business, or political change in the environment. Business and strategic goals may change, may be caused by the arrival of a new competitor in the market. Maybe laws and regulations have changed. Maybe now you have to collaborate with different systems. May also be caused by technology changes in the enterprise. So migration to a new operating system or database management system, or something like that. May be caused by organizational changes, right? Organizational structure may have changed, business processes may have changed, maybe new employees, different skill level, and so on. Now, what is requirements volatility? Requirements continuously change, and so while the requirements are being elicited, analyzed, specified, and validated, and after the system has gone into service, some requirements are usually more subject to change than others. So requirements volatility is to do with stability of a requirement, like how likely is a requirement to change. Stable requirements are concerned with the essence of a system and its application domain. derived from the client's principal business activities or the domain model, right? So the stable requirements are to do with the core of the system itself. It's based on the fundamental operations of that domain. They change more slowly than the volatile requirements. So for example, a hospital will always have doctors, nurses, and patients, right? So those are things that would likely not change. So those are the stable requirements. Then you have the volatile requirements. These are specific to the instantiation of the system in a particular environment for a particular customer at a particular time. So, for example, in a hospital, we can think of requirements related to the policies of the government health system, or maybe that town council, or yeah, something like maybe in Suva, there are some other regulations compared to in Lautoka. So the hospitals in Suva needs to follow different protocols, and so there would be some requirements that are depending on those protocols for that town, and so those requirements would be volatile. There are these types of volatile requirements: mutable requirements, emergent, consequential, and compatibility requirements. Right, so mutable requirements are what? These are requirements which change because of changes to the environment in which the system is operating. Okay. So requirements that change because of some changes in the environment for the system, those are mutable requirements. Emergent requirements, these are requirements which cannot be completely defined when the system is specified, but these emerge as the system is designed and implemented. Right? So these are requirements that emerge, right? So that's why they emerge when the system is being designed or implemented. So that is why they are known as emergent requirements. Then you have consequential requirements. These are requirements which are based on assumptions about how the system will be used. Once the system is in place, some of these assumptions will be wrong. Right? So as a consequence of our assumptions, we come up with some requirements, and they may change if our assumptions were wrong. These are consequential requirements. Compatibility requirements, these are requirements which depend on other equipment, technology, or processes. Expectations of requirement management. What are some expectations that we can have in the requirements management process? You have identification, right? This is where you expect that you will be identifying individual requirements. Traceability, from highest level requirements to implementation. Established via links. So traceability is established via links through a requirements database. The links between requirements and design models, the tests and code, right? They will all be linked to the requirements, and that's part of traceability. Coverage and consistency is analyzed. What are the traceability policies? What types of links should you have? From where to where, right? So we will look at that in traceability. You expect to carry out impact assessments of proposed changes. Analysis tools let you see if other requirements and other linked artifacts will be affected by a change. Furthermore, you have controlled access to current project information. A shared database ensures that all users are working with the current data, so that you maintain consistency and you have parallel access. A central repository allows all users to see the information that they need to see. And so you need to provide not only consistency and parallel access, but also visibility. Change control. Change proposal system implements a controlled process for managing change. And how do we collect, document, and address the changes? We will have a look at that. You expect deployment of required tool support. This will help to manage requirements change. Okay, so the first one, identification of requirements. It is essential for requirements management that every requirement has a unique identification. Okay, the most common approach is requirements numbering based on chapter or section in the requirements document. There are several problems with this approach. Numbers can be unambiguously assigned until the document is complete, right? You need to start numbering at some point, and you would have one set of numbers in one sequence. Assigning chapter or section numbers in an implicit classification of the requirements, it may mislead readers of the document into thinking that the most important relationships are with the requirements in the same section, right? Which is not always the case. Okay, so you can have sequential numbering, right? Or you can have dynamic renumbering. So some word processing systems allow for automatic renumbering of paragraphs and the inclusion of cross-references. As you reorganize your document and add new requirements, the system keeps track of the cross-references and automatically renumbers your requirements depending on its chapter, section, and position within the section. So you can think of, let's say you use Microsoft Word. You know how you use bibliography or referencing section there, and so as you do your work and you add in references, the references would be numbered, and let's say you have 1 to 5, 1 2 3 4 5, right? And then after you're done, you decide to add one more, and so now you get 6, but it's not the last one. You added something after number 3. So you had 1 2 3 4 5, and now you're adding a new entry after number 3. So now you have a new number 4, and the old number 4 will now become number 5, and the old number 5 will now become number 6. So you need to be able to manage that and have a dynamic renumbering, right? So is this similar to how we have references in Microsoft Word? So we have some tools that allow for dynamic renumbering. Another technique would be database record identification. When a requirement is identified, it is entered in a requirements database, and a database record identifier is assigned, which is then used for all subsequent references to that requirement. Symbolic identification. So requirements can be identified by giving them a symbolic name, which is associated with the requirement itself. So for example, here, these may be used for requirements which relate to system security. So you have security 1, security 2, security 3. So these are IDs for specific requirements to do with security. Okay, requirements have attributes. Apart from an identifier, so in the past few slides we looked at identifiers for requirements. Now we learn that apart from identifiers, requirements should also have attributes that establish context and background and go beyond the requirement description. So for filtering, for analysis, and for metrics purposes, right? Because you will end up with many requirements, especially for large projects, and you will usually need to filter out and analyze these requirements, right? So you need to have these attributes. So attributes could be things like creation date of that requirement, last update of the requirement, author of that requirement, stakeholders of those requirements, the owners and sources of those requirements. You would have version number, you would have status, priority, importance, and stability. You would have a rationale and comments for the requirement. You would have some acceptance criteria for the requirement. You would have subsystem or product release number associated with that requirement. Right? So these are some attributes that you would have with each requirement. The more complex the project, the richer the attributes will be. Many attributes are predefined in requirements management tools. Others are defined by requirements engineers as required by the project. Requirements attributes, some more notes. Classes and attributes of a requirements management database could look something like this. Select only the necessary attributes. So you have system models, requirement list, source list, requirements rationale. So this is an entire schema, right? And this schema has these entities, and this is the main entity that we've been looking at, the requirement itself. So the requirement entity contains these fields, an identifier. So these are the attributes that we were talking about. For each requirement, we'll have an identifier, a statement, date entered, date changed, sources, rationale, status, dependence, is dependent on, and model links and comments. Right. So, for example, you have this requirements list entity here, and these would be the entries here would be the dependents that are associated with each requirement. Right, what about requirement status? These help manage the requirement life cycle. Their number and nature depend on the process in place. Example of a set of statuses. Status could be proposed. Right, so the status of a requirement could be set to proposed. The requirement is proposed, or the requirement is approved, or the requirement is rejected. Right? So if it's proposed, it probably means that it's proposed by some stakeholder. If it's set to approved, probably means it's part of some baseline. Right? It was approved, so it's part of a baseline and it's committed to implement. If it's rejected, maybe after evaluation it was rejected. Implemented status would be that it's designed and implemented. Status verified would be its relevant tests have been passed. If the status is deleted, it could mean that that requirement has been removed from the list. So requirements management includes amongst its tasks the tracking of the status of all requirements during the project. So that was to do with change. No, it wasn't. Let's look at version control. Another essential aspect of requirements management is version control. Every version of a requirement needs to be uniquely identified. So it's not only the requirement that needs to be uniquely identified. When that requirement is changed in any way, that has to be uniquely identified as well. The last version of a requirement must be available to all team members. Changes need to be documented and clearly communicated. A version identifier must be updated with every change to the requirement. Okay, so we have a requirements identification. We also have version identifiers. Requirements document should include a revision history, right? What changes were made, the dates, and by whom, why were the changes made, right? So that's the revision history. Also, the requirements document should include standard markers for revisions, example, strike through or underline text, or coloring to indicate which parts have been changed, or you can have line markers. Version control tool may be used. So to store and manage the revision history, we can easily use some version control tools. To store justifications, to add, modify, delete, or reject a requirement, right? We can use version control tools. Now let's look at traceability. Requirements traceability refers to the ability to describe and follow the life of a requirement, right? Being able to trace the life of that requirement in both forwards and backwards direction. Its origin through its development and specification to its subsequent deployment and use, and through all periods of ongoing refinement and iteration in any of these phases, right? So that is requirements traceability. A software requirement specification is traceable if the origin of each of its requirements is clear, and if it facilitates the referencing of each requirement in future development or enhancement documentation. So you can only trace if your initial details were captured. Traceability gives essential assistance in understanding the relationships that exist within and across software requirements, design and implementation. Traceability is a link or relationship defined between entities. Traceability is often mandated by contracts and standards. Example, in military and aerospace, you must carry out traceability. One cannot manage what cannot be traced, right? Traceability information helps assess the impact of changes to requirements, connecting these requirements as well as requirements for other representations of the system. Traceability is a property of a system description technique that allows changes in one of the three systems descriptions, the requirements, the specification, or the implementation, to be traced to the corresponding portions of other descriptions. So you are able to trace back from requirements to the specification to the implementation and backwards. The correspondence should be maintained through the lifetime of the system. Okay, importance of traceability. Requirements cannot be managed effectively without requirements traceability. A requirement is traceable if you can discover who suggested the requirement, why the requirement exists, what requirements are related to it, and how that requirement relates to other information such as systems designs, implementations, and user documentation. What are some benefits of traceability? If you are able to trace effectively, you can prevent losing knowledge. It supports the verification process. So times when you need to certify in localization of defects, when some problem has occurred and then you try to narrow it down to like which module is the problem in, right, or which area of the system is the problem stemming out from, right? So localization of defects, when you're trying to narrow it down, then this traceability will be very beneficial. It's also useful for impact analysis, for change control, for process monitoring. Example, missing links indicate completion level. Improved software quality. This makes changes correctly, and so this allows you to make changes correctly and completely. Another benefit of traceability is re-engineering. You define traceability links in a way to record reverse engineering knowledge. Reuse, by identifying what goes with a requirement. So when you're designing or when you're coding, you can easily refer back when you're trying to reuse some application, some software. It helps in risk reduction. So example, if a team member with key knowledge leaves, then the rest of the team can still they can learn about certain aspects of the software that member who has left knew about and the others didn't. Since you have well documented traceable requirements, the rest the remaining team members can figure it out. Traceability is difficult though, and here are some of the difficulties faced. Various stakeholders require different information, so you are only able to capture just so much data about a requirement, right? When you saw the entity diagrams in the schema, in the entity of the requirements, you can only fit in the general attributes, but you don't know, some stakeholders may require some other information which we have not kept track of, right? So that's difficult. You have a huge amount of requirements traceability information which must be tracked and maintained. Manual creation of links is very demanding, so likely the most annoying problem, right, is creating links between the requirements. So you have this requirement in security which is related to one requirement in logging in, or another requirement in page display or something, right? And so you need to, every time you make a change to the requirements, you have to update all the links, and so that is very annoying. You need to use specialized tools, integrating heterogeneous models or information to or from different sources, Requirements design, test code, documentation, and rationale. It is not trivial. Requires organizational commitment with an understanding of the potential benefits, right? So it can be, if a software team or software engineers are not experienced, and they work on some product or some software, they might leave out traceability because at first glance it does not look very important, right? So but it is very important, right? There are many benefits of traceability. So it requires the organization to be committed to it, to recognize that traceability is important, and we need to keep track of the requirements. Okay, let's look at backward and forward traceability. Backward traceability is two previous stages of development. You're going backwards. Let's say from design phase to requirements document to business plan. That's backward. It depends on each element explicitly referencing its source in earlier documents. Then you have forward traceability to all documents spawned by a document. Depends upon each element in the document having a unique name or reference number. And so that's forward traceability. From business plan, track it to the requirements document and track it to the design specification. And in the entire software engineering process, it would move on forward to implementation and then testing. Top to bottom, from requirements point of view, right? From requirements point of view, it's top to bottom. Forward to traceability, this links other documents which may have preceded the requirements document to relevant requirements. It helps in validation. It helps evaluate which requirements are affected by change to users' needs. We have forward from traceability. This links requirements to the design and implementation components. Helps assure that all requirements have been satisfied. Okay, so that was top to bottom point of view. Okay, now we look at bottom to top from requirements point of view. Okay, going from bottom to top, backward to and backward from. So backward to traceability links design and implementation components back to requirements. Helps determine why each item is designed or implemented. Backward from traceability is it links requirements to their source in other documents or people. Helps in validation. Helps evaluate how changes to requirements impact stakeholders' needs. Okay, types of traceability that we can have. We can have a source traceability. This links requirements with a person or document, right? Where did that requirement stem out from, right? What's the source? So it's likely going to link to a person, a stakeholder, or some document. We can have a rationale traceability, which is like giving a justification, reason why we have this requirement. We can have a requirements traceability. This links requirements with other requirements which are in some way dependent on them, right? So requirements traceability is talking about linking the current requirement to another requirement. Then we have architecture traceability. This links requirements with the subsystems where these requirements are implemented, particularly important where subsystems are being developed by different subcontractors. Okay, and then we have design traceability. Links requirements with specific hardware or software components in the system which are used to implement the requirement. Then we have interface traceability. This links the requirement with the interface of external systems which are used in the provision of the requirements. We also need to be able to trace features. So feature traceability and test traceability. This links requirements with test cases that verify that requirement. It's used to verify that the requirement is implemented. Then you have code traceability, so generally not directly established, but it can be inferred. Okay, so here is a representation traceability table, right? It shows the relationship between requirements or between requirements and other artifacts. The table can be set up to show links between several different elements. It's backward and forward traceability. It's all present in this table. Difficult to capture different types of links in a table. So for example, you can see there's a user requirement, it's functional requirement. So user requirement UC28. It's related to what? Which functional requirement? Catalog, query, sort. That's the functional requirement that it is related to. Design element, it is related to the class catalog. Code module is catalog.sort. Test cases for this would be search 7 and search 8. Okay, so this is an example of for the entry of user requirement UC28, and here's UC29, which has its own details. Now this is a representation of traceability using a traceability matrix. So previously we looked at the traceability table. Now this one is a traceability matrix. It defines links between pairs of elements. So example, requirement to requirement, or use case to requirement, or requirement to test case. It can be used to define relationships between pairs. Example, it specifies or it is specified by. Right? So for example, R4 is specified by R2, something like that. Or depends on. So for example, R1 depends on R3, or is parent of, or constraints. Right? So it's defined by those relationships. More amenable to automation than traceability table. So if you are using automated tools to keep track of your requirements, right, you need to have something that has that is more notational and less less English words, less verbal. The traceability table has words, and it would be difficult to work with in automation tools. Whereas if we have something like this, it would be easier to use with automation tools. Then we have a traceability list. So first we looked at traceability table. Then here's a traceability matrix. And now traceability list. Traceability matrices become more of a problem when there are hundreds or thousands of requirements, as the matrices become large and they are sparsely populated. A simplified form of a traceability matrix may be used where, along with each requirement description, one or more lists of the identifiers of related requirements are maintained. So for example, you have the requirements here and depends on. With the traceability matrix, you had the relationship depends on, and you have all the requirements listed this way and all the requirements listed this way to identify which requirements depend on which. Right? So requirement 4 depends on requirement 2. Requirement 1 depends on requirement 3. Requirement 1 also depends on requirement 4. Requirement 2 depends on requirement 5 and requirement 6. So something like that. Now, to have a more compressed view of that, we can have requirement traceability list. So requirement 1 depends on requirements 3 and 4. Requirements 2 depends on requirements 5 and 6, and so on. Right? So this is a more compressed view, takes up less space. Now, traceability planning. Yes, just like any other project, you need to plan traceability as well. Who are the stakeholders? What are the needs? Making analysis reports. Useful, measurable, and feasible objectives need to be set in place. Definition of links and attributes. Can some be inferred automatically, or do you need to define them? Process, who collects and when to collect traceability information. How often should you be collecting this traceability information? The roles and who has access, data and link input and updates. Exceptional situations, example, if you have lack of time, if you don't have enough time to do all this traceability and record all this data, what do you do then? Do you have a backup plan, right? Representations, queries, tools. So traceability policies define what and how traceability information should be maintained. So factors to consider during planning. You need to consider the number of requirements you have. The greater the number of requirements you have, the more the need for formal traceability policies. You have to consider the expected system lifetime. More comprehensive traceability policies should be defined for systems which have a long lifetime. You also have to consider the maturity level of the organization. Detailed traceability policies are more likely to be implemented and used properly in a cost-effective way in organizations which have a higher level of process maturity. You also have to consider the size of the project and the team. The larger the project or the team, the greater the need for formal traceability policies. You also need to consider the type of system that you are working with. Critical systems such as hard real-time control systems or safety critical systems need more comprehensive traceability policies than non-critical systems. Additional constraints from the customer also needs to be considered. So example, compliance to military standards and so on, right? Or if it's a health or medical policies that need to be considered. Traceability links should be defined by whoever has the appropriate information available. So let's look at traceability links. So link source object type, for example, system requirement. Link target object type, the software requirement. And information source is the system engineer. Right, so these things need to be considered. Now, modeling the traceability. The types of links to use and their attributes must be defined for different types of requirements. It is a design problem. It may be modeled with a UML class diagram, so that makes it a meta model, right? Because the traceability model itself is trying to describe, or it's storing information about the requirements. And now we are making a class diagram for the traceability, for keeping record of requirements. Alright, so that makes it a meta model. It's a model about the model, right? That's why it's a meta model. Okay, so modeling the traceability with the UML class diagram, you need to have object types, object attributes, structure of folders, modules, and objects, the link types or associations. You would have things like satisfies, tests, refines, contains, contributes to, threatens, justifies, and so on. You have link attributes. Okay, the types of traceability links. Note that the types of links in the previous examples, as well as the types of objects they relate, like satisfies or tests, refines or references or contains. Others could be created like contributes, contradicts, justifies, depends on. Other examples of traceability links include these. And here you have change request modifies this, change request modifies business requirements. And so these are the links. Now how about cardinality of the traceability links? Depending on the traceability information, the cardinality of traceability links may be one-to-one, one-to-many, or many-to-many. One-to-one would mean, for example, one design element to one code module. One-to-many would be, for example, one functional requirement verified by multiple test cases. Okay, so that's an example of a one-to-many traceability link. One functional requirement verified by multiple test cases. Or you can have many-to-many traceability links. For example, A use case may lead to multiple functional requirements, and a functional requirement may be common to several use cases. Let's look at baselines. So what is a baseline? It's a non-modifiable, a read-only version of a document. It describes a moment in time. It may include multiple documents at the same time. A baseline enables document comparison and management. It comes with a change history for the document. It contains information on objects, attributes, and links created, deleted, or edited since the creation of the baseline. It often also contains information on user sessions. For example, when the document was opened, who opened it, and who edited which part, and so on. Baselines require access control. It is advisable to establish a baseline for a new document that is imported into the document management system in order not to lose any changes. So baselines for requirements. So baseline is a general term, right? It's not only used in software engineering or requirements engineering. It's a general term. Now let's look at baseline for requirements engineering specifically. So baselines in requirements engineering specifically, it represents this set of functional and non-functional requirements that the development team has committed to implement in a specific release. Before going into the baseline, the requirements should be reviewed and approved by stakeholders. Once in the baseline, all changes should follow a defined change control protocol. So let's say time is going this way, right? So time is going this way. You are at this point you are eliciting, analyzing, specifying the requirements, right? So you're trying to understand requirements at this point. Everyone has different viewpoints. There's no formal documentation. Requirements are always changing, right? And then at some point here you have discussed with the stakeholders and everybody has agreed on the requirements at this point, right? So when everyone has reviewed and approved the requirements, that is when you take a snapshot of that document, your requirements, and that becomes the baseline. So any change that you have afterwards, it needs to go through change management process. It needs to so from that moment onwards, for the baseline, everybody has a shared understanding of the system. You no longer have different viewpoints. Also configuration management has to be taken care of, right? So uses of a baselines may be created. This is the complete image of requirements state at a given time when the baseline is created. Baseline can be deleted, can be visualized, it can be compared to see changes since a certain time, can be copied, signed for authorization and contract purpose. Okay, let's look at change management. Change management is concerned with the procedures, processes, and standards which are used to manage changes to a system requirements. Change management policies may cover the following. The policies may cover the change request process and the information required to process each change request. It will also cover the process used to analyze the impact and costs of change and the associated traceability information. It will also cover the membership of the body that formally considers change requests. Also, the software support, if any, for the change control process. And so all those are part of the change management policy. A change request may have a status as well as requirements. Example, the status of a change request could be, okay, a change request is proposed, or it is rejected, or it is accepted, or it is included. So those are the status of change request. Okay, let's look at the change management process. Some requirements problem is identified, right? So firstly, some problem is identified in the requirements. It could come from an analysis of the requirements. So let's say you were taking a closer look at the existing requirements and you found there was a problem that's identified, or a new customer, there's some new customer needs that has come up, or operational problems with the system, right? So The requirements are analyzed using problem information, and requirements changes are proposed. So firstly, the problem is identified, right, and then the change is proposed. Then the proposed changes are analyzed. How many requirements and, if necessary, system components, right? So how many requirements or system components are affected by this change that is proposed? Roughly how much would it cost in both time and money? Then you move on to this phase. The change is implemented. So if approved, a set of amendments to the requirements document or a new document version is produced. Of course, this should be validated with whatever normal quality checking procedures are in place, right? So first, you identify the problem analysis and change specification is done, change analysis and costing is done, then change implementation is done. And then you end up with the revised requirements. So either the requirements version will change or the entire documents version will change. Now we have the change request form. This is for proposing the change, right? So proposed changes are usually recorded on a change request form, which is then passed to all of the people involved in the analysis of the change. Change request forms may include these fields: a date, customer, the requester, product including the version, description of change request including a rationale or explanation of the change and reasoning of the change, fields to document the change analysis, signature fields, status of the change request field, and comments field. Now let's look at change analysis and costing. An example, let's say a change request came in. You check request validity. You could either reject that request, but if it is a valid request, then you move forward here. You find directly affected requirements, right? So if you were to implement that change, what other components would be affected by it? So you refer to the requirements list, right? You find the dependent requirements. So you are now looking at the requirements change list. So you propose requirements changes to all those other ones that are affected, right? So if that is, if let's say that particular requirement that is now being affected, it is going to be, it also requires changing to accommodate the initial change that's proposed, right? So if that needs changing, so you have to check again. Can you change it? It is valid or not? If it's not valid, then you have to reject the request. If it is fine, you can accommodate it without hurting the system. Then you make the requirements changes. So you assess the cost of the change and you come up with the cost information. So you assess the cost, check if you can accept it or not. If it's too much, you would reject the request, or you could accept the change. Okay, here, when you reject the request initially after checking its validity, customers may misunderstand requirements and their context and suggest unnecessary changes. So sometimes you will end up rejecting the request. With the help of traceability information, you would find the dependent requirements, right? Using this requirements list that we looked at earlier. Consequential changes may be unacceptable to the user or the customer, right? So if the consequences are not acceptable, then we have to reject the initial request. You have room for negotiation, especially with cost, right? So if cost or time required for the implementation of change is too high, or it's going to take too long because of the change, then you may reject the request. Or if the risk is too high, then again you reject the request. Okay, the different management aspects. You have change management. How does a customer submit a change request? How is this request being monitored or prioritized and implemented? And so those are some aspects that you can look at. Another aspect is configuration management. Here, configuration management is talking about the versioning of the documents and the requirements, labeling, and tracking code and other components during the development cycle of software. Other aspect of management is release management. This defines how and when different hardware and software will be made available together as a product. Alright, some tool support for change management may be provided throughout requirements management tools or through configuration management tools. Tool facilities may include electronic change request forms, which are filled in by different participants in the process. That is very easily implemented these days, right? The simplest thing you can think of is Google Forms, right? You can just set up a form that will automatically fill in, analyze, and you can send links via the internet and so on. So that's electronic change request forms. Then another tool could be a database to store and manage requests, a change model which may be instantiated so that people responsible for one stage of the process know who is responsible for the next process activity. Or you can have electronic transfer of forms between people with different responsibilities and electronic mail notification when activities have been completed. You can have electronic signatures, you can have discussion forums, you have lots of collaborating platforms these days, right? So those are some tools. In some cases, direct links to a requirements database can be set up. Let's have a closer look. What kind of tool do we need? Different companies will use different tools which may or may not be tailored to the requirements management task. You can have word processor like Microsoft Word with templates, or you can have spreadsheet like Microsoft Excel. Again, you can have a template. You can have industrial strength or commercial requirements management tools. Example, you have IBM's Telelogic, IBM's Requisite Pro, and others that are used in industry. Or you could have internal tools. You can have open source requirements management tools. You can have bug tracking tools, which could be free or could be proprietary. You can use collaboration tools, again, which could be free, available, or proprietary. And what should we look for in a tool? We can look at the types and attributes for requirements and links, the specifications and models that are available, version and change management features available in the tool, database repository, traceability, if we can set up traceability tables and matrices in the tool, analysis, impact, completeness, style, and differences, right? If we can analyze the requirements, automatic inspection of requirements according to some rules, right? So notation based tools, visualization and reports, right? If you can create graphs and reports in that tool, you can look for requirements document generation. If there's an automatic requirements document generation feature available, monitoring of requirement statuses, access control, different users to have different levels of access. If you can import and export with that tool, communication with stakeholders, right? So if everyone can collaborate using that same tool. How about scripting language for automation, reuse of requirements, models, and projects? So, okay, are you allowed to set up templates and so on, right? So those are some of the things that you can look for in a tool when it comes to requirements management or automation. So one example architecture of such a tool could look like this. You have a requirements database, which provides you with a requirement browser. You can have a change control system attached to it. You can have a report generator, so the system generates reports. You have a traceability support system set up as well, which produces the traceability report, right? So all these subsystems or functions that this tool might have. So requirements management implies integration. That's basically what it means, right? You have requirements management tool. You need to integrate with project tracking tool. You need to integrate it with a version control tool, right? You need to integrate it also with a design modeling tool. You need to integrate with a project estimation tool, change request tool, a test management tool. So all these will be integrated, and keep in mind, you can see that these modules, right, not just the requirements management tool, but all these modules, they have to do with the various phases of the software engineering lifecycle. Okay, let's look at some approaches to document or database. Requirements have to be stored in such a way that they can be accessed easily and related to other requirements, right? So you need to have some kind of atomicity, so you can link requirements to each other, right? So let's say if you document, for example, you just use Microsoft Word to write down your requirements. That's all you do. You're documenting your requirements instead of storing in a database. So here with documents, it's easy to use, it's very easy to access, and you don't need to learn much. It's simple training, right? You just probably have a Word template and you just fill in the fields, right? Requirement 1, requirement 2, requirement 3, and so on. The requirements are all stored in the requirements document. It is easy to produce the final requirements document. But what about all these functions? Traceability, status reports, granularity and of the requirements, right? As I mentioned, the atomicity, searching and navigating the different requirements. How about change management, version control, and coming up with the analysis and reports? Right, simultaneous access control, how do we deal with that? So with just a documentation approach, you can just record your requirements, but you cannot easily carry out all these other functions. With databases, it's good for management, for controlled access, for creating links, for analysis and producing reports. It's good. You can have good query and navigation facilities with database. If you're looking for something, you can run a query, whereas if you're documenting, you can't do anything like that. And there's support for change and version management in database. You could archive a database and create a new version, right? So there is support for version management, but it is hard and costly to configure and to manage and to use. Right? Link between the database and the requirements document must be maintained. So the final requirements document must be generated. Ideally, you target the benefits of both. Right? So for example, some of these tools, they offer integrations with Word. You can import and export as well as document you can save it as a database, but it is also document oriented views are offered. How about evolving the process itself? Evolution of requirements types. So you can add, modify, and delete, right? So attributes and link types and requirement status. So these things would be evolving. Evolution of change management, you could be adding, modifying, or deleting, right? So you have evolution of requirements types and evolution of change management. The list of potential criteria and the list of products can be rather long, right? So you have these studies that you can refer to, about 25 tools and 80 criteria with explanations are given here. So you basically have to see which are relevant to you and to the context, to the project, and to the organization or the software engineering team. You need a goal model to define criteria and for assessment. Okay, this is one of the collaborating tools. Let's look at its overview. It's a generic wiki tool. It promotes collaboration. It's database driven. Access and version control is available. You have forms and queries. It's state-based workflows or processes. You have text and graphics. It's lightweight and extensible, so you can add plugins to make it more customized. Example of forms and queries are available here, so you can try those. Some requirements for library and for use cases, right? So you can try those. Further look at TWiki for requirements management. Let's check out its features and how you can implement requirements management using TWiki. So for example, it would look like this. You want to add a new requirement, you fill it in, and you click create. Here requirements name format is supposed to be like this, REQ, and then the name of the requirement. Right? So for example, this requirement already exists. REQ action redo many. Okay, so its description says that system should allow the user to redo many of the latest transformations or actions undone on the UCM model. Okay, so that's what this requirement means. It's a functional requirement. It's optional. It's not mandatory. It has low priority. What is its status? It's already implemented. What other requirements does it depend on? It depends on requirements action undo many requirement, which is requirements action undo many, this one, right? So this requirement depends on this requirement. Also requirement action redo one, which is this one, requirement action redo one. You can see that these have become links, so that means if you want to find this, you can probably click on it and it will take you to which requirement it is dependent on. Right, so that's the linking that we were talking about earlier. Here let's see an example. Okay, what is happening on this screenshot? So here it looks like we can see collaboration. So this team member Daniel has written something. He's written, this is an important feature that may impact how the model is maintained. Does EMF help here? So he has asked this, and then another team member can go and reply, like Jason has replied here, right? So collaboration is implemented there. It's available in that tool. Also you have a form for creating new requests. It looks like here you have a request name which automatically becomes linkable, and you enter its description, its type, importance, and so on, right? And the person who created that request is the author. Right, and so the the table for the request, also table for requirement looks something like this, right? You have these fields. You have a requirement name, description, type, its importance, priority, status, author, dependencies, verification approach, test cases, and details about the table fields are here, right? So TWiki allows us to create a table for the requirements, and what you can do with that table is you can edit it, you can attach a file to it, you can have a printable version of it, and there seem to be some more functionalities. Right, so using TWiki, we have requirement types description with configurable statuses and attributes. We have bidirectional links or wiki words as they're called in that tool. You have configurable requests, filtering and reports. You have access control and version management showing the differences. You have change management, again with forms, processes, and etc. You have discussions, right? As we saw, the team members were commenting. You have attachment of documents or images available. You can export. You have scripting language in Perl language available. Okay, what things do we not have? I think we don't have with TWiki these things. The graphical view of traceability is not available. Editable tables like in Excel or Word. Baselines and tool integration. Can you import, do more analysis? Let's look at another tool, IBM Requisite Pro. Right, so this is another tool. Here you have 3 interfaces. You work the way you want. It can be either document centric like Word or database centric like Excel. Right, it's your choice. You can keep your team on track, so collaboration is taken care of. You can have types, attributes, and views. So it's a lot like Microsoft Access, if you can remember. You can save views in there, right? So that's a similar thing happening here. You have user-defined requirement types, user-defined attributes, user-defined filters or views. You can save the views. You have functionality of traceability, right? So you can trace your changes of your requirements. Also, you have a facility for change management, and you have integration options, so you can integrate with many other tools. For example, you can integrate with IBM Rational Test Manager. Testers view current state of requirements from their own tool that they use for testing. You can integrate with IBM Rational XDE and IBM Rational Rose. So many of these would have evolved a lot by now, because it's been years, right? So this is very efficient and useful tool. Okay, so that ends our lecture.